they've been doing it in offices. I think they haven't done it already. My office upstairs, and it is, it's nice. All right. So first, before I get going, got questions? Any questions about the homework or anything we've covered? Yeah.
I had a question about how to do exercise 21.
21?
Yes.
Yeah. You have to know what page number? This is chapter 2.
There's only certain ones that
Chapter
have answers.
1, page
So
1,
like,
I'm pretty sure.
we get the exercise, like, so I'm not gonna say video solution. But the other ones, I just have to look up on
Where
mine.
you found the video solution?
Well, exercise with the-
Exercise what?
21.
Is that cancer? I don't still put that out.
Oh. A machine makes errors at a certain operation probability P, and there are two types of errors. The fraction of the errors of type A is alpha, and fraction of type B is, what is the probability of K errors in operations? Now, I'm not going to quiz you on this, but I want to tell you, this is the classic binomial distribution problem. Are you familiar with this? We covered it a little. So, if you talk about an event, and you talk about any event at all, and it has a probability P of success. So say P is going to be a success. And just call it that. 1 minus P would be a probability of failure. You follow me on this? These are binary type things. So 1 minus P, I think he calls it Q in the book. And this is the classic binomial thing. So if you think about this, you remember when we talked about permutations and combinations. This is a combination problem because order doesn't matter. The only thing that matters is the total number. Do y'all follow me on this, class? So it'll be n factorial, where n is the number of things selected. Then it'll be over k factorial. That's the number of successes we actually want to find. You'll see this in a second. Then it'll be times n minus k factorial. Now that is the combination definition. Do y'all remember this? How many different ways you can take things? N things, k at a time. Then you multiply this by p, which is the probability of the success, times k, and then multiply this by q, or 1 minus p, to the n minus k. Did you read this in a book where you talked about this? This is the binomial, really, distribution type of thing. Remember, this thing is binary, success or failure. You can't have a marginal success, if you know what I mean. It's not a continuum. So if you look at this, the way this is, I like writing this is P, and we want K, it's the probability, I call it P, but it doesn't matter. P of K n. Now here he says the probability is P, right, for success? And then he calls it A, doesn't he? He has two events.
Yeah.
If one happens, the other doesn't. It's binary, right? All right, so what is this question about? And then we'll get to the answer. What does it say there?
I think I don't have it pulled up, but I think it's the two events, it's K1 and K2, and it's asking the probability that the event K1 happens, I believe.
Here, just read that. I don't want to wear my glasses.
It says, part A is, what is the probability of K errors in operations?
All right, that's it. You look at the solutions? He has those online on the in the video.
I haven't been able to access those video solutions actually.
Yep. How many can access it? The video solutions.
I can't either, but if you just look up Stanley Chan chapter, whatever, exercise, whatever, it'll pull it up.
Can you send me an email? I'll send it to you. Now, does anybody have access to it right now? Because I want to just see if he talks about and shows that.
I do.
You do?
Well, he does it, it's just very confusing.
Huh?
I said he does it, but he doesn't really explain what he's doing.
Yeah, he just pretty much-
You know what he's doing? So first he takes the combinations, right? Now, if you know how many combinations are, you got to get the probability right for success and the probability right for failure. But since it's binary, if there's a success, there's not a failure, and vice versa. So that would be the number of successes. And you want to do a good example of this? Take die, all right? Now, if you have a die, because with die, I'd have to explain the event space being like something like a 1 or a 3, and then defining this, and that would be a probability of 1/3 of a success, and then I have to do all the permutations. But combinations. What's probably easier to do is pennies, and flipping a coin, tails or heads, all right? So if you think about this, and I'm going to just apply that to the actual coin flipping, just let me write this down. So basically the probability of a success is equal to the probability of failure, and it's 1/2. First, you gotta make sure you see this. This is going to be the classic coin toss. You don't need to write this down, but if you listen, hopefully I can answer. Y'all with me? Because I'll extrapolate to something a little more complicated. And I want to know the probability of 3 heads in 5 tries. By the way, if you looked at the solutions, did he have that, what I put up there in that form? He did. Now, I want to tell you, that is for that many, exactly that many successes out of that many tries. If you wanted to know, for instance, what would be like the probability of having, say, 3 or more successes in 5 tries, then you would have to sum up the probability of 3 successes plus 4 successes plus 5. Y'all follow me on that? That's cumulative. But back to this thing. Exactly 3 heads in 5 tries. Going? If you look at this, well, that's going to be 5 factorial over 3 factorial, and then we take 5 minus 3, or 2 factorial. Now I've got the combination in front of this thing, right? The nice thing about this, the probability of a head or tail is the same for a fair coin, right? So this becomes simply 1/2 to the k, or 3, and then it's 1/2, and it'd be n minus k, or it's going to be 2, and that's simply 1/2 to the 5th. Y'all follow me, class? If you get that, it goes to simply, well, 5 factorial over 3 factorial means I have 5 times 4, or I basically have 20 over 2, or 10, and then I have, well, this is going to be 1/2 to the 5th power, right? So that's really going to be 10 30-seconds, isn't it, class? And that's really, that's the simplest example of this, but you can extend this to any number of coin tosses and stuff like this. And that's the likelihood or the probability of getting exactly 3 heads, if you define as success, out of 5 tries. Now, if you wanted at least 3, then it would be that 3 plus that with 4 plus that with 5. And one thing you're going to see about this thing, if you took this and you sum this for k equals 0, basically none, to n, you will get 1 every time. I'm trying to answer your question without spending too much time on binomial. We'll use this later with combinations. Now, if it's something where the probability of a success is 1/6, say we roll 1 die, we're rolling dice, but we're gonna have k rolls, all right? And we want the probability, and we have to define our event, of the 1 being a success. Y'all with me on this, class? So then, if I come down here and I use this, and I'm going to say the 1 is a successful roll, everything else is. So the probability of k, and actually let's do it this way. Say of 5 successes in 5 tries. That means it should be 1/6 to the 5th. Do you agree with that, class? Everybody with me on it? It should be. So what is that going to be? Well, that's 5 factorial over 5 factorial and 0 factorial. Well, that is 1. Agreed, everyone? 0 factorial is 1. Then I have, well, the probability for success would be 1/6 and I want it 5 times, and the probability of a failure in this case is gonna be what? 5, 6, right? Y'all follow me on this? And it would be to the 0 power, correct? Y'all follow me? Because it would be n minus k if k and n are the same, and 5 to the, or anything to the 0 power is 1, correct, class? If you look at that, what do you get? Exactly get 1 over 6 to the 5th. Follow me? It works. That thing does work. It shows you exactly the right value. That's what he meant by that exercise.
But that's just the first part. I guess where I started to have issues.
What was the second part?
It's, what is the probability of a K1 type A error in operations? Where the,
Say that again. A K.
what is the probability of K1 type A errors in
K1?
operations? Where the fraction of errors.
Is
that
he
are
using
type A-
K1 as a variable?
He's saying that out of the errors, there's 2 different types, which have different probabilities of
Okay, yeah.
happening.
Well, you're talking about the probability if you take this of having, if of a success, call it P, all right? And then if that is done, right? Now I'm assuming this, whatever is not a success is a failure. Do you agree with that? Well, then, now read the problem again.
So it's asking for, I'll just read the problem statement. A machine makes errors in a certain operation with probability P. There are 2 types of errors. The fraction of errors that are type A.
Oh wait,
is
it doesn't
alpha.
say they're linked though. Right? It doesn't say if error 1 occurs, error 2 doesn't, does it?
Well, there's just 2 different. There's type A is alpha, and then the type B is 1 minus alpha. So
Oh, all right,
one-
it is just two. All right, so it's like